أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Welcome to the students of class 12th. Today we will continue our topic about alcohols, and today we will take up preparation of alcohols. Number first is from alkyl halides. Preparation of alcohols from alkyl halides. When we react alkyl halides with aqueous alkali or moist AgOH, we get alcohols. Here in this case, this is our alkyl halide, and we react it with aqueous KOH or aqueous NaOH or moist AgOH to get our alcohol. This is the alcohol, and in turn we get Kx, salt. That is salt. This is the strong and nucleophilic substitution. Here the nucleophile is strong and the attack takes place from the rear side, that is back side, and it involves inversion of configuration and no carbocation is formed. That is why this reaction is SN2 reaction. SN2 reactions are those reactions which involve strong nucleophiles and the attack occurs from the rear side, and which involves inversion of configuration. No carbocation is formed. Here is the example. This is alkyl halide and this is aqueous alkali, and here we get the alcohol. This is our alcohol. So second method of preparation is from alkenes. Number first of this category is hydration of alkenes. That is, addition of water is called hydration, as we all know it. It takes place in two ways: direct and indirect. In case of indirect method, alkenes are passed through concentrated H2SO4 to form alkyl hydrogen sulfate. This upon hydrolysis with boiling water to give alcohols. That is, alkenes are passed through concentrated H2SO4. Here this is our alkene. And it is passed through concentrated H2SO4. This is actually H2SO4, and we get what we get. We get alkyl hydrogen sulfate. This is our alkyl hydrogen sulfate. This alkyl hydrogen sulfate, and this upon hydrolysis. Later on, this is hydrolyzed. To get our alcohol. This is the alcohol. इसको हमने बाद में हाइड्रोलाइज किया with water, put H positive, and in boiling water we hydrolyzed it to give our alcohol. Now in case of unsymmetrical alkanes, addition takes place in accordance with Markovnikov rule. Now what is Markovnikov rule? Markovnikov rule is in case of addition reactions of alkenes, of unsymmetrical alkenes. This is unsymmetrical alkene. The hydrogen goes to that carbon atom of carbon-carbon double bond which has more hydrogens linked with it. which has more hydrogens linked with it. That is here this is our unsymmetrical alkane. This is unsymmetrical alkane, and this is our sulfuric acid, and the hydrogen of this H2SO4 goes to that carbon atom which has already linked with more hydrogen atom here, and the hydrogen from this इस सल्फ्यूरिक एसिड का हाइड्रोजन जो है वो इस कार्बन एटम के साथ उसने लिंक हो गया, and the OH goes to this carbon atom. This is the Markovnikov-Cox rule. That is, the hydrogen goes to that carbon atom of carbon-carbon double bond having already more hydrogens linked to it. That is, this carbon atom. इस कार्बन एटम के साथ ऑलरेडी जो हाइड्रोजन लिंक्स थे वो थे 2. इस कार्बन एटम के साथ एक ही हाइड्रोजन लिंक था, तो जो यहाँ से जो एसिड से जो हाइड्रोजन निकला वो हाइड्रोजन इस कार्बन एटम के साथ जाकर उसने बॉन्ड बनाया, and the OH goes to this carbon atom. That is our Markovnikov's rule. So now the direct addition. So in case of direct addition, reactive alkenes add directly a molecule of water in the presence of mineral acids. As a catalyst. These reactive alkenes they add this mineral acids directly as a catalyst. Here this is our reactive alkene. This is our reactive alkene, this one, and it adds directly with mineral acids to form alcohol. This is our alcohol. This is the alcohol which is formed here. This alcohol. This is also Markovnikov's addition. This is also the example of Markovnikov's addition. That's here this hydrogen of the water or hydrogen of this mineral acids goes to the carbon atom having more hydrogen atoms. This one. इस कार्बन के साथ ये जो एसिड का हाइड्रोजन है वो इस कार्बन एटम के साथ बॉन्ड बनाता है to form this CH3. तो mechanism of this reaction is, so far as the mechanism is concerned, the mechanism of hydrogen of alkenes involves following 3 steps. यहाँ पर this mechanism जो है that involves 3 steps. First step is electrophilic attack of hydronium ion on alkenes to form carbocation intermediate. ये जो हाइड्रोनियम आयन का जो अटैक है, इलेक्ट्रोफिलिक अटैक जो हाइड्रोनियम आयन का है on alkenes, it attacks on alkenes to form carbocation. First of all, this is our sulfuric acid. It gives 2 H positive ions and SO4 2 negative ions. This H positive ion later on reacts with water to form this hydronium ion. Later on, this hydronium ion reacts with our unsymmetrical alkene. This is the unsymmetrical alkene, and this is our hydronium ion. This reacts with this hydronium ion. What happens here is that the loosely bound pi electrons here in this carbon-carbon double bond, they form coordinate bond with the hydrogen of the hydronium ion. With hydrogen of the hydronium ion. For example, this here is the loosely bound pi electrons. They form coordinate bond with this hydrogen. So this form coordinate bond with this hydrogen, and this positive charge appears to be here. यहाँ पर ये पॉजिटिव चार्ज अपीयर होता है किस जगह पर? here. इस कार्बन एटम पर पॉजिटिव चार्ज जो है that is appearing on this carbon number 2. here we get this carbocation. यानी इस एल्कीन से जो लूजली बाउंड पाई इलेक्ट्रॉन्स बिटवीन कार्बन नंबर 1 एंड कार्बन नंबर 2 जो हैं, ये हाइड्रोनियम आयन के साथ बॉन्ड बनाते हैं एंड देयर बाय यहाँ जो इलेक्ट्रॉन की कमी वाक़ा हो जाती है, उससे इस कार्बन नंबर 2 पर पॉजिटिव चार्ज डेवलप होता है टू फॉर्म द 2 डिग्री कार्बोकैटायन. यहाँ इस कार्बन पे भी पॉजिटिव चार्ज अपीयर हो सकता है, मगर दैट कार्बोकैटायन वाज लेस स्टेबल. दैट इज़ वाई हियर 2 डिग्री कार्बोकैटायन इज फॉर्म्ड. तो दूसरे स्टेप में what happened in the next step is that the nucleophilic attack by water on 2 degree carbocation to yield protonated alcohols. इस कार्बोकैटायन पर later on nucleophilic attack होता है किसके ज़रिए? वाटर के ज़रिए. This water attacks on this carbocation to give this product. Actually it is here. यहाँ पर इसका फोटो नहीं आया है. Actually it is here this. यहाँ पर O and H, this, it is like this, and the positive charge appears here. यहाँ पर positive charge. This is the nucleophilic attack by water on 2 degree carbocation to form CH3. CH3 और C पर ये जो वाटर का अटैक है, it forms bond at this carbon number 2. तो in the next step में क्या होता है? deprotonation और loss of proton to form alcohol. नेक्स्ट स्टेप में डीप्रोटोनेशन. यहाँ पर अगर हम देखेंगे तो यहाँ पर इस वाटर मॉलिक्यूल का जो इलेक्ट्रॉन पेयर है, ये जो है इट एब्स्ट्रैक्ट्स दिस प्रोटॉन ऑफ द complex which is formed in step number 2, so that we get this alcohol, propane to all. This is our alcohol. So in the third step, what happens? In the third step, there happens loss of proton to form alcohol. The number second is hydroboration oxidation. So dear students, this diborane B2H6 is an electron deficient molecule, and thus it acts as an electrophile and reacts with alkane to form trialkyl borane which upon subsequent oxidation yields alcohol. यहाँ पर here this is our diborane. So this diborane, this is BH3. It is deficient in electrons. How? Because this boron has only 6 electrons. There are only 6 electrons. This boron, 2, this, and this. That is why this is deficient in electron. This is deficient in electron, BH3, and it acts as electrophile. And reacts with alkane. इस alkane के साथ ये react करते हैं to form trialkyl borane. It forms trialkyl borane. How it forms trialkyl borane? This is our this is our alkene, and this is the diborane, HBH2. Here what happens, this H goes to carbon number 2, this H goes to carbon number 2 here, carbon number 2, this H goes to this carbon, so that we get CH3, CH2, CH, and this BH2 goes to this terminal carbon CH2. Later on एक और अल्कीन मॉलिक्यूल इसके साथ ऐड होकर हमें क्या प्रोडक्ट मिलता है, CH3, CH2 होल ट्वाइस, BH इस H के बदले। ये स्टूडेंट्स यहाँ आप थोड़ा गौर कीजिए, जो इस BH2 का H है, दिस BH2, इस एक H के बदले एक और एल्कीन यहाँ पर ऐड होता है, तो हमें प्रोडक्ट मिलता है CH3, CH2 होल ट्वाइस। क्यों? क्योंकि यहाँ पर एक और एल्कीन ऐड हुआ। BH इस H के बदले, जो यहाँ H था, इस H के बदले एक और एल्कीन ऐड हुआ। लेटर ऑन वन मोर एल्कीन गेट्स एडेड, so that we get the product CH3, CH2, यहाँ 2 के बदले 3, because one more alkene has been added instead of this hydrogen. The name of this product is trialkyl borane. So here it is trialkyl borane. So what happened? Diborane is an electron deficient molecule, and thus it acts as an electrophile and reacts with alkane to form trialkyl borane. This is our trialkyl borane. उसके बाद this trialkyl borane upon subsequent oxidation, उसके बाद इसकी ऑक्सीडेशन होती है। इस trialkyl borane की ऑक्सीडेशन होती है in the presence of hydrogen peroxide, so that we get 3 molecules of alcohol, propanol and boric acid. And another product which we get here is the boric acid. So अब तक हमने इस हाइड्रोबोरेशन के बारे में क्या पढ़ा? This hydroboration is actually this diborane, which is deficient in electron, acts as electrophile and reacts with alkane to form trialkyl borane, which upon subsequent oxidation yields 3 molecules of alcohol. So what is the mechanism here? In case the mechanism of this reaction is BH3. तो यहाँ पर क्या होता है? So this pi electrons between these two carbon atoms, this pi electron starts to develop the positive charge at this carbon number 2, and this BH3 starts making the bond with this terminal carbon atom BH3 having slightly negative charge. तो later on क्या होता है दूसरे स्टेप में? this carbon starts making bond with this hydrogen here. This carbon starts making bond with this hydrogen, and this, जब ये कार्बन इस कार्बन के साथ बॉन्ड बनाना चाहता है, दिस बॉन्ड, तो नेचुरली दिस बॉन्ड स्टार्ट्स ब्रेकिंग. ये क्या होता है? ब्रेक होता है. दिस बॉन्ड स्टार्ट्स ब्रेकिंग हियर, एंड this bond also starts breaking. This double bond breaks to form single bond, and here this bond starts forming. That is, we get 4-centered cyclic transition state. 4-centered cyclic transition state. Later on, to next step में this gets bonded to this carbon atom. We get CH2 here. यहाँ पर CH2 हमें मिलता है, तो यहाँ पर हमें BH2 मिलता है. One hydrogen goes from BH3 to this carbon atom. So we get addition product. Later on, one more alkene gets added to form CH3, CH2, CH2 whole twice BH. Later on, third molecule of alkene gets added to form CH3, CH2, CH2 whole thrice B. This is our trialkyl borane, which we actually need. This is the product, and this product later on, upon oxidation, yields our alcohol. This is our final alcohol, propane 1-ol. So my dear students, I think this is enough for today. Have a great time ahead.